Hello and welcome to an algebra tutorial video learning about linear inequalities. In this video we're going to be doing a linear equality word problem. We're going to be tackling a problem that involves greater than or less than and being able to interpret it into the right inequality and then solving it out. Okay, so here we go. We got Jeremy is saving up his money to buy a car. He currently has $650 in savings, but he figures that he needs to save at least $3,000 to buy a decent car. If he makes $175 a week at his job, how long will it take for him to save up at least $3,000? Okay, so first thing I want to do in a word problem, I want to define my variable. I want to say, okay, I'm going to have an unknown variable, x. What is x? Well, let's go to the question. The question is, how long will it take for him to save up at least $3,000? So x is involving units. I don't know how long something will take. So my unknown is how long or how many, in particular, weeks. I'm making $175 a week. How many weeks to save up? To save $3,000. Okay, so that's what I'm trying to solve for. That's going to be my unknown. So now let's try and put together an equation then that uses this variable and all the other stuff. So I know currently Jeremy has $650. So right now he's got $650 in the bank. Now every week he's making $175 more. So I'm going to add to that $175 every week. Well, my unknown number of weeks is x. That's what I'm trying to find. So how many weeks, how many times do I have to add $175? So I'm going to do 175 times x, the number of weeks it'll take. So that, now let's interpret it. What does it mean to have at least $3,000? Well, that means it could equal $3,000, but he just wants to save greater than or equal to $3,000. All right. So I think we used all the details in this problem. This is how I would interpret those words and rewrite it as an algebraic linear inequality. He's got $650 in the bank. He's adding $175 per week. We have to multiply that by however many weeks it's going to take till the whole amount, both of these added together, is greater than or equal to $3,000. All right, I'm liking it. In any word problem, if you're turning a whole bunch of words, sentences, etc., into an inequality, you want to know that every number, every symbol, everything you write should have some meaning based upon what you read in the problem. All right, we've got this done. Now let's solve it out. I'm going to draw my line down. Let's find out how many weeks it's going to take here. First thing I want to do is subtract 650. It's a two-step linear inequality. So 650 minus 650 leaves 175 times x has to be greater than or equal to 3,000 minus 650 is going to be 2,350. So what that is saying is, well, he's already got $650, so that means from there on out, he's got to make at least $2,350 from working at his job, which he gets paid $175 a week. All right, now let's divide these. I want to find out how many weeks. So that's a multiplication problem, so I need to divide both sides by 175. That's the opposite of multiplying. And so x is going to be greater than or equal to whatever 2,350 divided by 175 is. And I get approximately 13.4. I'm going to round it to the nearest hundredth, 13.43. All right, now let's interpret this because the context makes a huge difference. So I can't just leave my answer there. I'm trying to, this is not my answer. X is greater than or equal to 13.343. That's not the actual answer. I need to answer this question of how long will it take for him to save up at least $3,000. If he makes $175 a week and you think about you get paid at the end of the week for what you do, well, 13 weeks is not going to be enough. The amount of weeks he needs to do has to be greater than or equal to 13.43. So then I need to go up to the next week. So the answer I'm going to be looking for is it will take Jeremy at least 14 weeks to save $3,000. I hope that 14 makes sense because you can't have a fraction. You can't have a decimal of a pay period, a decimal of a week. Every week, boom, $175. So we have to round it up to there's 14. Okay, there's an example of a linear inequality word problem using the language of at least, thinking about we have to have more than a certain amount and rewriting things as an inequality that we can solve.